Hi everyone, welcome to my lecture. Aha, welcome Kulani. Say hello sir, how can we see if faster than now we have to say R1 change to or hi Sita, hi I will come back to your question, Kulani Mbata. I'm not necessarily getting what you are asking specifically, but I will come back to you. So while we are waiting for people to come through, good morning, everyone. Hope you have yeah, Pradham is here, Berawala, and Muzo Sita is here, Kulani is here. Hi, everyone. Good morning. I hope that those who are fasting, they are okay. I know it's hard, so I'm gonna try to be as quick as possible. And I wish all those who are fasting a good fasting season. Good morning, Ezekiel. Good vibes. Okay, right. Yes. Timna, Mabija. Yes, Aidan. Welcome. Good morning. Uh, yeah, Ragnam is here. Ragnam, yep. Hopefully, I will say your name correctly. Don't be Anika. Good morning. So yeah, we're starting a little bit. We're just waiting for people to come through. But I want to get few feedback on. Okay, so yeah, today we have a quiz going live again. It's not very hard. Ryan, welcome. The quiz merely is 10 question. It's just same stuff like formulation of the equation, solving some two decision variable equation, just like those examples in the notes. So you should be able to do them. It shouldn't be very difficult. Hello, Tetelo, Sheshaba, SJ, Lungile, Andy Swandala. Yeah, good morning to all of you. So yeah, welcome guys. Basically, the quiz is not as hard. It's not hard, but it's long. So it is 10 questions this time. It is still 90 minutes. And this is opening from 12 o'clock till tomorrow midnight. So yeah, you do get 35 hours, but you can only answer in 90 minutes. There's a quiz of linear algebra part. No, Sita. I will be nice. I'm trying to bring everybody in to get some marks, and then I will become real. So yes, Sita, thank you for your question. Morning, everyone. Right now, before I continue, I want to do the first thing I want to do today. How many parts? 67. So I want to run an experiment. I want some people to recommend a class rep for my optimization course. And it must be, I think we have Pradham is a guy. And thank you for being nice. Shabir Mohammed. Right. Okay, good. Yeah, so does it mean you guys didn't understand the algebra part? What is happening here, Sita? Yeah, I was expecting that you guys like Ezekiel, bring it on. We got this. We're gonna crush you. Now you guys seem like so. I'm gonna introduce a little bit the algebra part, a little bit. Morning, sir. That happened when we are minimizing the variable so we can have the basic solution. Aha. Yes. So basically, there is a specific pattern you can follow to try to get the upper triangle. And actually, if you look on the notes properly, it should be clear. But I will check it and come back. I'm struggling with algebra. Sita, are you struggling or you haven't studied it? Like make a cup of coffee, sit down, and do it like for 8 hours a day. Like all hands down on algebra. I'm very sure you will conquer it. Don't just study like partially and says, I don't understand this. You study 8 hours non-stop pushing optimization. Okay, so does the quiz have the basic solution? No. The quiz doesn't have the algebra part is a very normal part. So I don't want people to start stressing here. Okay. All right, now I need before I start my class, as I say, I need a recommendation of a class rep who want to be a class rep for my optimization course. We already have a mail for numeric, so I was all right, sir. Please never forget. I will not forget. This guy is like a Liverpool supporter. It's like never forget. We never walk alone. Kulani, sure. Kulani Mbata, I hear you. Remind me at the end of the session as well. I'll chat. We can review the previous quiz. Of course, yes, I will actually make it live maybe end of this weekend because I just want to make sure that everybody else, those people who register last week, they still have to write it. That's why I didn't release the review of the thing, Nyeko. So that's a reason. We cannot release until everybody we have checked everything. SP sir is a test only on graphical method. Yes, Constantino has panic. Shuan, I also vote Pradham. So Pradham is already a class rep for numerics. Now I need a vote. I thank you, Mozo. Mozo said Pradham, but Pradham is already in for. We need somebody else. So we need two. We have Pradham already. We need a lady or any other guy. Anyone? Pradham is already a class rep. We just need another one. We can't have Pradham doing all the work himself. I vote Mozo. So is it Mozo a proper name or just some guy having this ghosty name? Can we have a girl? Yes, why not? Yes, any girl name, I vote Sita. Who? Okay, Sita. Who else? Okay, Sita is recommended. Is Sita a girl? I hope so. I vote Altwaf Ali. Is Altwaf a girl? Monday. Okay, all right. Now I'm gonna spend my day here all day long. Can we do this quick? So Sita again. So I got Sita 1, 2, Sita. You guys must know whether Sita is a girl, right? Oh, right. Is Sita a girl? No? Now this one, like, when looking for a rank, do we stop row operation once we... Okay, Sita. Uh, okay, yeah. Okay, Sita, you being voted. I'm not sure if you want to be a class rep, yes or no. Okay. So we have Pradham, then we are getting be nice, more blessing. Like seriously, I can't judge. My name is Ezekiel. How do you know whether I'm a girl or a guy? Like seriously. All right. Yes. Thank you so much. So yes. And this one now we have already. I'm gonna take Sita. I see people are voting, and this one now should really like and this one. So all right. So far so good. I am gonna now move on in my class because Shabalala, these guys just want to continue running with my class. I'm gonna just run with Sita. Sita came through early. If Sita ever have a problem, we can run again the experiment. So Sita, I don't even know her surname. What's the name? Sita. So Sita who? Where is this now? Sita C. So Sita, thank you very much. Please send me an email so I can send your contact to the course coordinator, Dr. Tama, and then we can take it from here. So email Ezekiel, send Ezekiel an email. So Sita. Yes, okay. Right. Thank you so much, guys, for coming through and giving me some names. Sir, I am a little confused. This one. Sir, I am a little confused with the linear independent. I was led to believe that the for a system being linear independent, that, but the one example but linear independent. Constantine is equal to AK is equal to, so A1, A2. No, it must be equal to 0 unless I made a typo. So correct that, Constantine. Yes, I see. So it could be a typo. So just double check. Thank you for checking this. Okay, democracy. What is this now? Democracy at its finest. Right. Right. Sorry, Julian. I hope it was democratic. Uh, okay, now does the quiz include simplex? No. Can I teach them? Yes. What's the quiz based on? The Ezekiel needs. The quiz is based on the previous work. It's just to consolidate your understanding with more questions. Some people ask me to give more questions while they haven't even answered all the examples in the note. Yes, who is going to struggle in my course. Those people who haven't done all the examples in the notes and they're busy saying, Ezekiel, can you please set up more quizzes? I can set up more quizzes, but if you don't read the notes, if you don't practice, my friend, I can give you all the quizzes in the world. You won't pass if you are not practicing enough. You need to practice examples in the notes, do your tutorials, be ready. Not like the content covered. Yes, like the content covered, but without linear algebra. The linear algebra part, I haven't put it there. I want to give a mini more examples on it before I start examining you, because I think maybe your understanding as well is not as good. So the previous quiz was inaccessible. I think it was an ICT problem. Okay, fine. I will check again and then see what is happening on my end, Leroy. Right. And as I say, by the end of the week, that will be happening. Okay, milk. Okay, so let me start. I need to start teaching because now we can sit here for ages. And sir, please allow us to review the first quiz before doing the second one so that we can see our errors. Unfortunately, it has nothing to do with the last quiz. If you did the work, we have people like Leroy who have not managed to write the quiz so far. So reviewing or not reviewing is not important. Do your quiz, do your tutorial, you should be able to do that. So I can only release the review after next week. So sorry. Who is this? Tando. For 8 hours, right, Ezekiel? What is 8 hours now? I can write both today if possible. Yeah. You have to study for 8 hours, my course. Right. When is our test and what will be in it? Amo, are you ready for my test? Some people are tata my chance. Okay, fine. I will tell you when is my test, and you better be ready. And I'm gonna look at you, Amo, specifically. These people. Right. Okay. Good morning, Amo. I will announce when the test is up. You will see it on Moodle. You will see it on Discord. You will see it everywhere. Right. Okay. Good morning, everyone. Welcome back. I hope you are well. For those who are fasting, I wish you a blessed month of fasting. For those who are studying as hard, I wish you productive study as well. So today, I want to start Simplex Method. Hi, sir. Hi, sir. So the quiz is only graphical. Okay, guys, I think you should ask this question at the end of my lecture, so I can answer all of them. So, Nis, yes, the quiz does not include the linear algebra part. Okay, so let's start. Okay, guys, so let us start. So today I want to start Simplex Method, and as I spoke last time, we're going to use Simplex Method to answer. So we're going to use Simplex Method to answer a linear programming problem which have a multi how do you call this, multi-variable or a multi-decision variable. Now, the basic here is we're using some algorithm to be able to, can we follow some instruction like doing row operation to solve the linear programming problem? Now I'm going to the simplex problem, or the problem with the multi-variable decision variable, right? So it has from x1, x2, x3 to x4 to x5. Not only, which means you cannot draw it graphically. So what you need to do is to solve it using a method called simplex method. Simplex method is very easy if you just follow the instruction and understand what you're supposed to do. Okay, right. So it's literally like a 2-dimension, but we are just doing it for multi-variable. But it has certain rule, and the certain rules are very important that you must be able to follow for you to be able to to do the question, right? So I'm going to start with a very basic example. I'm going to explain the rules, and then we're going to do a few examples, and then you will get to do some examples, and then you get to do some tutorial question as well. Tomorrow, actually, I don't want to give you a tutorial. I think those 10 quizzes, if you use the time to revise all your examples in the notes, revise the previous quizzes, tutorial you have written, and write that quiz. The quiz have 10 questions. It's 25 marks. You should be able to do it in less than 90 minutes and get all the marks, right? Some are really easy. It's just to try to see whether you have it's like there's a true or false question. So they are not amazingly difficult. Okay, so let me start. So fundamental theory of linear programming problems. So there is a fundamental theory. So if you consider a linear programming in a standard form, so you're minimizing z equal to that, where this is your constraint is a vector of that multiplied by the vector of x, subjected to ax is equal to b, where you have a non-negative constraint, which mean that this cost thing belong to a real natural numbers. B as well belong to that. Then we have a matrix with a size m times n, where m is less than n. So if there exists a feasible solution, then there exists a basic feasible solution. So a feasible solution was the solution we got that is what? So we could find the area where all our constraints are satisfied. If we can find a region where all our constraints are satisfied, we can shade that region and then find a solution which maximize or minimize our objective function. So we call it a feasible solution. Now, if there is a feasible solution, then there must be a basic solution, a basic feasible solution. A basic feasible solution is one of the solutions which you start with, but it is not the maximum solution. It could be just a simple solution, it works, but it is not the optimal solution, right? Right. So if there exists an optimal solution as well, then there exists so if there exists an optimal feasible solution, then there exists an optimal solution. So if we can get an optimal solution, feasible solution, i.e., you could get that at 1 is correct, you can still get an answer. That's not necessarily the best answer, but it is an answer. Then you move to maybe a point where you have a 2, and when you substitute in it is still satisfying your constraint, and it's satisfying your objective function. That still is a solution, but not but not the optimal. But if you can find an optimal feasible solution, then there exists an optimal solution as well. So these are just definition of impact, and you need to know really nice algebra to be able to do this. So the good news is you just have to remember the statements. You don't have to remember the algebra proof about it. If you grow up and you make it in life to actually grow up and go to second year, third year, masters, honors and masters, you will start now seeing how to develop this thing. Because I still want you to continue reading my course, I'm not going to ask you to prove. No proof in this thing, because I still want you to continue being in this class. Right. Last time, now I'm going to talk about another concept. But before I talk about 3.10, I just want you to a little bit bear with me, so I can come and show you something which might make my explanation easy. So what I want to show you is a graph. Which one? Which one is a good one? Ezekiel, find a good one. Probably this one. So this graph, I want to show you extreme point in this graph. So 0, 0 is an extreme point. A is another extreme point. B is another extreme point. C is another extreme point. D is another extreme point. So these are the points which are in the outward of your feasible region. We call them extreme points. So 0, we start at 0. Then we go at A, then another extreme point is A, another extreme point is B. So these are like points which encircle the feasible region. So those are what we call extreme points. Now, how linear programming works, if you write an logarithm, remember we are looking which extreme point give me the solution. So how a logarithm of simplex method work, it starts from 0, for example here, and then it go and check here, is it maximized? So it will calculate this point, that point, that point, that point, and that point, and then choose which one give the value of z, which is maximum, right? If it cannot find, for example, here there are 2 points which are, so if this is like there are 2 points which could be a solution, what it does, it finds a weighted average of these 2 points as a solution. And that's when we said we had multiple solutions, if you remember, right? So how the algorithm of simplex method work first is that it starts by looking for a solution on the extreme point, which are the point on the envelope of the feasible region. So remember, this is my feasible region. Extreme point is A, is this point, that point, that point, that point, that point. So what the algorithm then does is search from here, solve there, solve there, solve there, solve there, and choose. If A was the point which maximized, then it will say the solution is A. When B is the solution, then it will say B is the solution. When it is a combination, then it does a thing called a weighted average. So that is what we call, you get a multiple solution where we're getting what? A convex solution, which means in that aspect, you have what? This aspect where you have B and C being a solution happen only when one of the constraints have the same slope as as the objective function. So if one of the constraints have the same slope as the one of the objective function, then then it will have a multiple solution. Okay, for example, you see here there's an 8, 8. That's why my solution becomes something like this. Okay, now I'm going to continue because that's what I wanted for you to know. What do we mean when we talk about extreme point? Okay, so let me now explain extreme point. So a point X of a convex set, omega, is called an extreme point of omega if there are no 2 points X and X1 such that if you take this weight, you weight this X by lambda. This lambda can be any number which lie between 0 and 1. As I say last time, it's some form of probability. And 1 minus lambda X is equal to X. For lambda is belonging to a closed interval 0, 1. It means that the extreme point is also a point that does not lie strictly within the line segment connecting to other points of the set. This is not very important. I'm not going to ask you this. I just wanted you to know that whenever there is a solution where you are finding two solutions which are the same at the point, you take the weighted average of it, and this is how it works. So no one is going to ask you to do that, right? Okay. Alternative, if X is an extreme point and X is equal to this and this, for that, then X must be equal to X1. Let us use an example to illustrate this. Okay, so let the R0 be determined by, so you have this, this scenario where you have X1 plus X2 plus X3 is equal to 1, and X minus X2 is equal to 0. Of course, we have always to have our non-negativity constraint. Note that R0 is a linear segment joining the point when X1 is equal to 1 and 1 and then 0. So if you make X1, if you make X3 0, you can say this then has to be half a half for this condition to satisfy, right? So if you make X3 0, X1 can be solved as that, and X2 can be solved as this, right? Okay, so this is not very important. You don't have to remember this, or you don't even have to just read it. And if you understand it, if you don't understand it, we will do examples where you see what I'm talking about. Okay, so the theorem as well, let omega be a convex set consisting of all feasible solutions, that is all n vectors x satisfied ax equal to 0, and then x is an extreme point of alpha if x. So when I say if, it's not a mistype, it merely means if and only if x is a basic feasible solution to ax equal to b. Now I know this all sound Greek, so please no panic. My objective here is for you, actually you'll understand these things when you start doing the examples. I always think that the English is so confusing. When you read the English and you go do the example, you're like, this is what Ezekiel mean. He was just speaking Greeks on the other part, but now I follow what he's trying to do. Right, okay, so of course there is a simplex algorithm. So a simplex algorithm, I can give you an example, is something you write, and then you write some instruction of which, if you feed some input in it, it will give you some feedback. For example, if you come to my class and you follow all instruction, you get an A. If you come to my class and sleep during my lecture, you get a D. If you never come to my class, but you are on Moodle, you get a 0, right? So those are the possible output, but there are rules on how this algorithm work. For example, go to Ezekiel class, do the tutorials, do the exercises, and you get some marks. Don't go to class, don't do Ezekiel assignment. Think Ezekiel just have a funny voice. You will thank, right? Maybe that's not a very good algorithm, but we'll have better algorithm later. But there are many algorithms. Actually, you should learn how different algorithm work. Algorithm is nothing else, but it's some rules you design to help you solve problems quickly. If you have written all the rules and impose all the restriction, it means if you put any input, it should give you a solution, right? Holding all else constant. So the aim of the simplex algorithm is to move from one basic feasible solution to another until an optimal basic feasible solution is found and the minimum value of the objective function is reached. So a basic feasible solution is optimal if and only if the corresponding reduced cost coefficient are all non-negative. Okay, so what does this mean? Okay, so let us go to a table and I show you what I was talking about. I'm going to use the previous example as well to make your life easy. So a feasible solution, right? Ezekiel start here again and he says, so notice that these are the point, right? So all these are feasible solution, but so A, it was what, 0, 6, and then B, 2, 6, and then C, 4, 4, and then D, that. So your solution then should have been either at B or at a combination of B and C because they have the same thing. If you are to look this one, it will start from 0, 0, then go to A, go to B, go to C, and then go to D. So you calculate all of them and check which one have the maximum. So that's what the algorithm will do. So you write a restriction that find at this point, check at this point as well, check at that point as well, check at this point as well, and check at this point. So you check all your extreme point and choose the one which is maximum. So that is what we are doing when we talk of a solution search on the extreme point. Okay, so let me continue again. I'll give an example. So don't you worry, I'm using this one to just build my story. Right, so I was here. So the aim of the simplex algorithm is to move from one basic feasible solution to another until an optimal basic feasible solution is found and the minimum value of the objective function is reached. A basic feasible solution is optimal if and only if the corresponding reduced cost coefficient are all non-negative. Now I'm going to explain what is a corresponding reduced cost coefficient and how do we go about calculating it, right? So a basic feasible solution is optimal if and only if the corresponding reduced cost coefficient are all non-negative. What is this now? We are not going to talk about the proof here. For the algorithm, I want to do the algorithm using an example. So you read this, but if you don't understand this, let us go to an example to build this, right? Okay. Okay, so let me start here and then I can explain what it works. Okay, so the simplex method can be examined by selecting a pivot column, Q, and a row, P. So the pivot column is Q with the most negative element in the top row of an argument matrix. The W is called the optimal in the third step if all entries are non-negative in the top row of the W. Okay, so I hear now it's like Ezekiel is speaking Latin. What is a W? What is a row? What is a pivot row? What is a pivot column? So, all right. Now, how do we go about this? So in the simplex method, we want to move from one basic solution to another until an optimal basic feasible solution is found. To improve the W, the pivot row P is calculated by attaining the minimum ratio in the step 6. That is Y dot over that, where the entries are found in the last column of the canonical argument matrix. Okay, I know the English I've just explained to you doesn't make sense. Probably you are half confused as it gets. Now let me use an example. So if you cannot understand the English, understand the example. Example explain what I'm trying to achieve quicker and easy. Okay, so I want you to tell me how many constraints I have in my equation. How many constraints do I have in my equation? Let me stop here and hear your comment. How many constraints, class? How many constraints does Ezekiel have? How many constraints does this question have? Malindiso is laughing his head out. It's like, you, right, come through. How many constraints do I have in that linear programming? Somebody. Sita say 3. Yes, that's correct. Why 3? 3 as well. Bonkanke Zulu. Who else? Is that guy who thinks there are 7 of them or 8 of them? 3 constraints. Nice. And this Wakubeka. Thank you. Who else? Yeah, Leroy, excluding non-negativity constraint. Nice. You see, guys, that if we don't count the non-negative, so I'm gonna get free marks. Next time, I'm gonna just ask people how many constraints are they. They are busy telling me 3, while there are 4 of them. I get free marks, Mahala marks. There are 4 constraints. Non-negativity constraint is included. Yes, that is true, Constantine. We are transposing the thing. Yes, that's correct. Because your 3 function. 4. Aha, yes. So please never make a mistake that non-negativity constraint don't matter. You will get into serious trouble. Anyway, now that you have figured that, I shall go back and now continue. So you have this one, you have this one, you have that one. Right. Now, the first step is to put our problem in the standard form. Now, some people are like, Ezekiel, how do you put an equation in the standard form? The easiest thing is to start with this, start with the objective function, move all the thing to the left of it. So it might be z minus 4x minus 5x equal to 0. Is that clear? So that one, you move everything so putting in the standard form, move this into the left. So the first step in solving a linear programming problem using simplex method is write it in the standard form. How do you go about writing it in the standard form? You start by looking at taking the objective function, move it to the left, equate equal to 0. That is what I've done here. I hope everybody can see this. So I move everything to them. Now, for my constraint, listen carefully. For my constraint, whenever there is a less or equal to, you add a thing called a slack variable, which allow you to introduce equality. You add something called a slack variable, which allows you to introduce equality. So for example, this is 2x1 plus x2. I'm going to have to add x3, and I say equal to 9. So here is 2x1 plus x2 plus x3 is equal to 9. I hope you have understood that. Now, when you're adding this slack variable, in each constraint, you add a unique slack variable. You do not add the same slack variable in all equations. In the first one, I already have x1, x2, x1 and x2. So I'm going to start adding x3, x4, x5 to allow equality. So here I add x3, and in the next one, I will have to add another slack variable to allow me to equate to 4. So it's going to be x1 plus x4 because I've already used x3 here. So here I'm going to have to add x4. And then in the last one, I'm going to have to add x5. Any question before I continue? Any question? Did you understand this part? Same mistake I did in my quiz. Shame, Pradam. Just be strong. We in South African language, we say Zoba strong, something like that. And study more. Why are the slack variables positive? Aha, because this is a minimization problem. We because the sign are less or equal, we add. If the sign were greater or equal, we minus. I like Michael, this guy. Michael Germans. That's a very good question. So because we have a less or equal, we add. If we had a greater or equal, we minus. Thank you, Germans. Michael, you are a genius. Thank you. Somebody says, do slack variables only apply for less than or equal to equality? No, it says that less than or equal to, right? So yes, that is what, or greater than. Can we represent the slack variable with the S? Of course you can. No one is going to, just make sure that you are consistent, right? And then you uzoba strong pradham, right? Okay, so right. So since the second constraint doesn't have x2, we don't have to add it since it is in the first constraint. Yes, we don't. And this also, say, uh, you are not changing anything. You are merely adding a slack variable to allow equality. You already know that you have x1 and x2. So the basic things now to do is to just add. So here you already have x1 and x2 in this constraint. So if you are going to introduce for equality here, you add an x, you add an x3, here you add an x4, here you add an x5, right? So you now have, look now, everything have equality. So now I can say there is x3 here, x5 there, x3, x4 here, and x5 there. So now I have written my equation in the standard form. So if I give you this and I say write it in the standard form, you should write something like that. Right? Now, of course, we're now going to have to put this thing in something called a Tableau before we continue. Now, I have a footnote, and I didn't write it here for decoration purposes or to add stuff on your life. So it says, if all of the ratios A1, K are non-negative, in this case, none of the basic variable will become 0, and the interest variable increases. Hence, the entering variable can increase infinitely. So this is a, if you get that, I will explain later that if all your ratios are negative, then you have an unbounded problem. But for now, don't worry about it. I'm just putting it here. If you are very, very keen to know how does it become unbounded when you have doing simplex, that is how it goes. Now, I hope everybody have got what I did up to here. So the next thing I'm going to do is to put this thing, to put, how many new variables did I introduce in my equation? Let me ask that question. How many new variables, slack variables, did I introduce in my equation? Let me check. What is your comment? How many new slack variables did Ryan Shimon say 3? What are they, Ryan? 3, Kosi. Please tell me 3 and what are they? Hope, thank you, Hope Nisi. Yes, 3, that is correct. Anyone else? What are those variables? Ah, that's easy, 3. Yeah, okay. It's fine. It's fine. It's like Ezekiel. Like, you don't think we are smart. Don't undermine us. Right. So yes, those now we call those basic variables. Right. Thank you so much, guys. I'm very glad that you are following. My worry was maybe my class will just be balancing all the time. So we introduce that as new, that as new, and that as new, and we call them basic variables. Now, when I come to put my equation in a what? In a tableau, you first write z, right? So of course we have the first variable is z. So z, x1, x2, x3, x4, x5, b, and r. Please don't worry about the b and r. It's not necessarily immediately feasible. But from z, here, z is what? So again, so on horizontal term, you write your z, x1, x2, x3, x4, x5. This side, you write z and the variables you have introduced, right? The slack variables you have introduced. We call them basic variables, right? So the variables have introduced. So notice that you write the z this way, z and x1 up to x5 this way, because I now have what? I now have 5 of them. So it's going to be x1, x2, x3, x4, x5, and then z, and then x3, x4, x5, because those are the new one I've introduced in my equation. Does everyone follow till there? Is there a question? Yes, that is correct. This is correct on what Aluzuko asked. So that is correct. Right. Any question on the fact that the way I wrote this thing? So horizontally, you put z x1 to the last highest x in your decision variable. Vertically, you write z and the basic variables you have introduced, which is x3, x4, and x5. Right? So that's what I wrote here. Now, if I go for my z equation, of course, for z, for a z equation, this part, you see that there's one z, and then for x1, what is the value of x1? It's a minus 4, and then what is the value of x2? The value of x2 is a minus 5. It's there. Is there in this thing? Do we have x2, x3, x4, x5, and x6, x5? There is no x3 here. There is no x4 there. There is no x5 there. So what those they are gonna take is what? 0, 0, 0, and the b value there is a 0. So that's why I put a 0 here. Correct? Right. Now, for the second one, it's gonna be, is there a z in this equation? No, there is no z in that equation. So for me, for this one, z is 0, x1 is 2, x2 is 1, x3 is 1, and then you have a 0, 0, and then equal to 9. Sure? For the second one, z, there is no z there, so z as well going to be 0. x1 is 1, there is no x2, there is no x3, 1 for x4, 0 for x5, and equal to 4. Then for the last one, z again, there is no z in this constraint thing, so z is going to take a value of 0. And then x1, there is no x1 either there, so it's going to be 0. x2, there is x2, there's going to be a 1. And then x3 and 4, there are none of them there, so those are zeros. x5 is 1 here, and then is equal to 3. Question of any question on how I put this thing in here? Did you understand, or is there a confusion? Yes, I'm talking about the values of a coefficient. Thank you. Yes, so that's what I'm talking. I'm only recording the values of the coefficient. Right. Okay. So I'm not sure what how is vector B calculated. Aha, vector B is calculated. That says right. Okay, how is vector B is calculated? Let me show. So vector B is nothing else but it is this, is this. These are the values. They are the equal values on the right hand side of your equation. So vector B for Z, what is the value for B? 0. I put it here. And for this one, it's a 9. I put it here. And then for this one is a 4. Did I answer your question? Did I answer your question? Is it what? Who was it? Michael. Never mind, I see. Ah, this guy's like Ezekiel. Never mind, continue, brother. Okay, fine. Now we have our fantastic matrix. Till here, I give you 3 marks in the test. In the exam, if you graduate getting up to here, I give you 3 marks. Here, you get 3 marks. You're telling me this, you get another 3 marks. There is no way you fail my course. It's just you being very, very arrogant and not doing the work. Okay. Remember, I told you I added what? I added the three. So I added what? X3, X4, X5, which is this way, by the way. Notice how they become a diagonal thing. It's a 1, 1, 1. Right. Now, what's the initial solution? The initial solution is to say that, so notice that the basic matrix is what? The basic matrix B is X3, X4, X5. Those are the things I have introduced in my model, right? It's a X3, X4, X5. Now, look, when I read that, let us see. When I say when X3 is equal to 1, it means what value does it take? It takes a value of 9. Is that clear, guys? When X3 So my basic, I'm reading my basic solution. When x3 is equal to 1, everything else in that column is 0. x3 equal to 1, it take a value of 9. When x4 is equal to 1 and everything else is 0, it takes a value of 4. When x5 is equal to 1 and everything else is 0, it takes a value of 3. So for me to read my basic solution, after I put in my standard form and I put in the Tableau, I say, what will the value of x3 be when everything else is equal to 0 in that column? So of course it's 1 is equal to 9, and then x4, when it's 1, b is 4, and then for x5, when it's 1, b is 3. That's how I get 9, 4, 3 to read when everything is what? So my first feasible solution then is what? Sorry, this should just have a few zeros. I see there's a typo. It should be a 0 for that, a 0 for that, and then what? 9, 4, 3. So that's a typo. I will correct that. Should be 0, 0, 9, 4, 3. Any question on this? That's how you read the initial basic solution. Initial basic solution, how you read it, you say when everything is 0, you look at the variables you've introduced, which is x3, x4, and x5, and you say for x3, when everything else is 0 and x3 is 1, what is b? Similarly for that, you say when everything else in that column is 0 and that is equal to 4. And then for that as well, that. Let me hear if there is a question before I continue. Guidance, is that a challenge, Ezekiel? No comment. Why do I need to temper with your faith, Kaden? We will see. Notice that there is a typo here. It should be 2 zeros only. And then 9, 4, and then why are the values of Z negative? Yes, I thought they were negative. Is the values of X negative? Is the values of Z not negative? Yes, there is a typo here. I explained that it should only be the zeros here are for X1 and X2. Anyone to help Julian? How do we find these? Okay, next question says, sir, why is it that all other variables zeros in the column and not rows? Because we are only looking for the solution of the basic solution, the initial basic solution. Yes, so the initial basic solution, that is correct. That is what we start with. Aha. I think it is because we did an additive, then we create the objective function that. Okay, right, yes, so we did that, and then let's see the Slack. Okay, so basically, I don't see a very exciting question to answer. So he says, can you explain this? Can you explain the starting basic solution again? Right, let me do that, and then I can continue. So somebody is asking, why do we have, so he says, of course, this is a negative number. If you are taking this thing equal to 0, and this number is negative? No? I think they are negative, last time I checked. So Z will be 1, and then for X1 it will have a negative 4, and that will be a negative 5. And here they are not negative, so of course they shouldn't. Right, as I say, here shouldn't be that. And then to read your basic solution is, these are the slack variables you have introduced. So to read your initial feasible solution, you go look where you introduce the basic variables, which is x3, x4, x5. And you say, looking at this, the basic solution only, if you are looking for x3, what will x3 value be when all other values in that column are zeros? of course, it is 1 equal to 9. So it means x3 is equal to 9. Similarly, for x4, when everything else is 0, it means x4 is equal to 4. When x5, everything in the column is 0, and you have 1, x5 is equal to 1, this thing equal to 0. Which means for x1 and x2, you are saying make them zeros. And then what will the solution be if we make x1 and x2 zeros? The easy way to say that, you could have just come here and say, if I make x1 and x2 0, what will x3 be? x1 and x2 0, x3 will be a 9. x1 again is 0, so x4 will be a 4. x2, we made it a 0, so x5 will be a 3. And that is how you get this thing. So making the original variables you have, which is x1 and x2 zeros, in your standard form and reading the solution for x4. So when x1 and x2 are zeros, x3 is 9. Of course, x1 is 0, so x4 is 4. x2 as well, we say is 0, so x5 is 3. So that is how I get this number. Right. I'm not going to dwell a lot here. Now, before we start solving, we need to figure out if are we maximizing or minimizing. If we are maximizing, we have to start with a highly negative number on the top row. So what are the on the top row of this matrix? What is the most negative number? Because to read your initial solution, Leroy, we had to let we have to let the other variables, the initial variables we have, equal to 0. Right, in the top row, yeah, -5, thank you. So that is a number we need to know, that we need to make sure that the most negative number is a -5. So if you are maximizing, you start there with me. Okay, so yeah. So we start with the most negative number on the top row, which is a minus. Right, so minus 5. Right, so that's what. So basically, what I have explained so far is how to read the basic solution, which I said, ignore x1 and x2. Check only look where you have introduced new variables. Look when it is 1, what number are they taking? When it's 1 as well, what number is it taking? When it's 1 again, look what number is it taking. So you have a 9, 4, 3. So your solution now, you're going to be 0, 0 for x's, x1 and x2, and then followed by x3 and x4 and x5, which takes this value. I will correct this. I see the typo before I upload. Okay. Now that you have got that, we now need to check what is the most negative coefficient, right? So how are we going to do that? I'm going to explain. So we compute the reduced cost coefficient corresponding to the non-basic variable x1 and x2, right? To calculate the reduced cost coefficient of x1, so we're going to talk about what? X1. Sure? Now, what do we have for x1? The first value is -4, correct? So we're going to say this is the formula, but I don't think you will see what the formula means. But I will just tell you it's a -4. And then you say minus, what number is this? Multiply by, so I'm going to say it's going to be a -4, which is this value, minus bracket. Then it's going to be a 2. So remember, we are looking for x1. So it's going to be a -4, 2 times 0, which is this value. So I'm taking this, I say -4 minus bracket, -4 minus bracket 0, which is a 2 times 0, which is this value. That is how I got this part. Plus 1 times 0, which is that value on x4. That is how I'm getting this. And then last one, I say 0 times 0, which is 0 times 0, and it should give me a minus 4. I'm going to repeat again what I did. To get the reduced cost coefficient for my matrix, what you need to do is to take a minus 4, and then you minus a bracket of these values multiplied by these values. To do it step by step, it's a minus 4 minus bracket, then a 2 times a 0. I'm not using x2 because x2 I already have it. I'm gonna find a reduced cost coefficient for this as well. So it's gonna be, for this one, it's a minus 4 minus bracket 2 times 0, 1 times 0, and a 0 times 0, and it gives me a minus 4. I need to see if you understood what I did. Any question? Right, so, and this will say, why do we look for the most negative number? If we are maximizing, we are trying to make that number as what? As big as possible. We are going to increase it, make it positive, become more positive. Yes, Sita, all the zeros come from the 0. That's correct. Okay. So did you guys understand how I found the reduced coefficient? The reduced cost coefficient, anyone understood? No? Confused? Sita, okay, yeah. Aha. How are those numbers corresponding with x1? Right. So x1, this is a column for x1. If I ignore x2, what are the numbers which are corresponding on this? So you take in this, you take the value on your x, then you minus a bracket of 2 times all these other basic values. That's what I'm doing. Meaning a minus 4 minus bracket, which is here, by the way, if you want to see, it's a minus 4 minus bracket. Then I'm saying is a 2 multiplied by that, and a 1 multiplied by that, and a 0 multiplied by that. And I hope that makes sense for you. Let me try to do for x what? Right. I want to do for x2. For x2, you have a minus 5 again, minus bracket, right? Now you're going to say 1 times what? Times 0, and then 0 times 0, and then 1 times 0. And it should give you a minus 5. By the way, you don't have to do this step if you understand what I am doing. It's just to check which one is the most highly negative number. In the top row, I didn't have to do what I did here. I could have just noticed that the most negative number is a number on which column. Let me see. If you can understand that, then we can skip. So what is what column and the most highly negative number is on which column? The column with what variable? Yes, let me answer this question. Then why do we pass the value from x2? Because x2 as well is a non-basic variable. So that's why I skipped it. When I was calculating for x1, I didn't use this because this is a non-basic. You are only reading it from the basic. So it's values here multiplied by the basic stuff. Here as well, I'm not going to use that. I'm actually going to take minus 5 and then minus this. This is a column vector multiplied by a row vector, and make sure that I get that. So what is the most negative number? Which column is it? Under what column is it? Aha, x2, second column. What is the point in getting the most negative number? Before you do the row operation Kwezi Magwaza, you need to first identify what is the most negative number. Okay, so you identify what's the most negative number in that in your in your in your top row, and then using that column you calculate a thing called ratios. Now that's where we are going next, so let me not spoil your party. Remember, there are marks for each step you do. Right now, if now, so we choose, you choose the column with the most negative number. We call that a pivot column. A pivot column is a column with the highest negative number if you are maximizing. If you are minimizing, the pivot column will be the column with the highest positive number on the top row, by the way. So the pivot column is a column with the, if for me, maximization is a column with the highest negative number. For me, it was -5. I put it in color red for you to see that the most highly negative number in the top row is in the column 2. So my column is that. Right. Now I'm going to calculate my what? My ratio. The ratios, which is R, is calculated by taking B, the value of B, right? Divide by the value in that column, in the column you have chosen, in the pivot column. So I'm taking 9 divided by 1. If you take 9 divided by 1, you get what? A 9. If you take a 0, divide by 0, it should be 0. Last time I checked. And if you take a 3, divide by 1, you get a 3. Right? Actually, what is 0 divided by 0? It should be what? Is it 0 or undefined? Zero divided by 0 is what? 0 or undefined? Undefined, yes. Right, so then here it should be a dotted line. So if you say 0, -5 divided by what? 0 divided by -5, we do not take negative. Why? The rows should never be what? The rows should never be negative. The ratios should never be negative. You can, if we have negative ratios, if you remember what I said, the ratios must always be what? Non-negative. So the best thing to do is make sure that your ratios are always non-negative or not undefined. Okay, so again, this one should be undefined. It should just be a dash line as well, because 4 divided by what? 4 divided by 0, it should be what? 4 divided by 0, it should be undefined. Right? So that should be undefined. So now we have a 9. So how did I get the numbers? Let me just explain. It's 9 over 4. It's 9 over 1, which means 9 divided by the number in the pivot column, and then what? 4 divided by the number in the pivot column, and then 3 divided by the number in the pivot column. Now, what is the minimum ratio? Which one will be the smallest ratio? Because we need to choose the smallest ratio. This is correct. Yes, it is a 4 divided by, yes, that is correct, which is undefined. So I will edit this and I will upload for you. So wait, why are you doing 4 now? Are you using the R column or B column? So we take the B column, the values in the B column divide by the values in the pivot column. So what are the values in the B column? There is a 0 divided by -5. We get what? We get a 0. We don't want a 0 either. Then you go to 9 divided by 1, you get a 9. Then you go to a 4 divided by 0, that's undefined. And then you go to a 3 divided by 1, you get a 3. So the minimum ratio is 3. Mandisa, thank you very much. Now, where you get the minimum ratio, so remember how we got a minimum, how we got a pivot column. A pivot column with the highest negative number on the top row. A pivot row is a row with a minimum ratio. Sure? So now, you see, now we have that, right? So I got that my pivot column was this by looking for the most negative number. Then I take these numbers, the numbers on the D columns, I divide by these numbers and I get my ratio. Then I choose my ratio to the smallest in the thing, right? This is a typo, it should be undefined here, so it's not 0. So the smallest should have been a 3. Now, so that is my pivot column. Now, remember, where are they meeting? X1, X2 is meeting with what? X2 is meeting with, where are they intersecting? At a point 1, which is at what? X2 and what are they? They are meeting each other with what? Horizontally, we have what? From 3, that is corresponding with X5, and the vertical one is corresponding with X. Yes. Now, I need to teach this very slowly. So this, you guys, it is a must that our ratio must be the smallest. Yes, always, until whichever God you believe with. Because Mandisa, when it is a 0, we don't take zeros. We don't want zeros. It must be a non-negative. It must be some number, not a 0. So yes, Mandisa, thank you for your question. So now, remember that they are intersecting between what? X. The logic here is what? We have that. So what we do now is to switch. You are going to take X5, put it there, and take X2, bring it here. So we are saying X5 is leaving the basis and X2 is entering the basis. Sure? What after we figure this thing, it means we're going to have to switch now. We're going to say X2 is coming here and X5 is going to go there. Right? So 1 is going to enter there, and then we do our row operation. So we say, so what is leaving the basis? X2 is entering the basis, and the X5 is leaving the basis. So this guy have to hammer, and this guy have to come here as we go towards solving the solution. That is the step we are going to have to do. What does that even mean? It means we got the pivot row to be that as a 1, and then everything else, and then as a 1. Everything else remaining, we now have to do row operation in such a way that all other numbers must be 0 in that row, in that column. So we do row operation to ensure that everything. So this number remain as 1, but everything else it should become what? Should become a 0 in the entire column. So we do row operation to make this thing it become 0. Every values in these things become 0. Of course, we already have a 0 here, so we need to make this a 0, and that is 0 as we perform those row operation. So the first thing is identify, put the thing in the matrix, find the highly negative number, that will be your pivot column, then use the B values, divide by the values in that column as well to get your smallest ratio. Then now from the pivot column, where the pivot column meet with the pivot row, that number stays as 1, and everything else in that column becomes 0. Do row operation to make them zeros. That is what we are going to do. So then we choose the minimum ratio, and we see that the 4th row is chosen as the pivot row. So of course, row 1, row 2, row 3, row 4. So that is 1. And then and then it should have been what? That have been the third column. 1, 2, 3, probably, if you are talking about numbers. Should be the third column, right? Then what are we going to do from there? From there, we now, so remember, my objective was to make what? I told you that I have chosen this to be I chose this to be my pivot column, my pivot row. I got this is a 1. I need everything else to be 0. Sure? So what row operation must I do to make this one become a 0? And what row operation must I do using this to make this become a 0? Okay, so Ezekiel says, because I want, what row do I want it to become a 0? It's row 2. So this is row 1, row 2. I want this to become a 0. So I'm going to say row 2 minus row 4, put it back into row 2. That's what I wrote here. Row 2 is the same as row 2 minus what? Row 4, putting it into row 2. When I do that, what is it going to be? It's going to be row 2, so it's a 2 minus 0, going back to row 2. So it's a 0 minus 0, going back to row 2. It's going to be 0. 2 minus 0, going back to row 2, is going to be 2. 1 minus 1 is going to be a 0. I have achieved my answer. 1 minus 0 is 1. 0 minus 0 is 0. 0 minus 1 should be a minus 1. And then a 9 minus 3 should be a 6. That's how I got that row. So look, that nothing have changed here. It remains the same. But when I do this row operation, I get a 0, 2, 0, 1, 1, minus 1, and I got a 6. Any question how I got that? My bad. Somebody comment is still here. Okay, so let me go explain again what I'm doing. I'm doing a row operation. I have this. My objective, as I say, this was what I got. It's a 1. I need everything else to become 0 in that column. So what I'm going to do, I'm going to do row operation to ensure that all this row everything else apart from this one in this column is 0. So I want to make this thing a 0. So I'm going to say whatever you want to, I'm going to say row 2 minus row 4 and put it back into row 2. So in my new Tableau, I'm going to write z is equal to 1 minus 4 minus 5. That is not changing. But for this one, I'm going to say row 2 is a 0 minus 0. It's going to become a 0. 2 minus 0 is going to be a 2. 1 minus 1, it becomes a 0. And that's why I have a 0 here. And then another one is what? 1 minus 0, it's going to be 1. 0 minus 0, it's going to be 0. Going back there, 0 minus 1, it should be a minus 1, and you can see it here. And then the last one is a 9 minus a 3, it should be a 6. So the only row which I have changed now, notice that what I did, I changed x5, I put x2 there. Why? Because that's what I'm trying to do. I'm trying to change x2. So that's why there is x2 here. And notice that this row, it changed out to what? To that objective. Okay. Now, the next thing I want to do, remember I told you, this remaining one, everything else has to become 0. Now I need these things to become what? I have managed to make this a 0. Now I need this to become 0 as well, no? What row operation must I use to make this 5 become a 0? Which row operation should it be? Let me see. Maybe people know. Tell me the row operation I must do to make the top row 0 where there is a negative 5. Okay, impress me or disappoint me now. Go. Sir, even if it is the greatest than that, should the minimum be? Sir, if it is greater than, should the ratio be the minimum? The ratio is always the minimum value. Whether you are maximizing or minimizing, you always take the minimum ratio to be your pivot row. Thank you, Constantine. Just not taken, not that. Yes. Why do we switch, sir? Because we are trying to solve for the solution of x1 and x2, which maximize my objective function. Remember, we want to solve for those x1 and x2, which maximize our objective function. You will see how we're going to get that. Okay, some people are coming through. Zobas. Some, of course, I know you are copying this from the notes. If okay, fine, but thank God. Some people are saying this is true, and I guess that is true. Some people are writing Latin. Wena unamanga yazi. That cannot happen, Kwezi. It's a raw operation. If you do that, you are going to get a negative -1. You are not going to get a 0. This is not correct. Kwezi, you are not following. Andisa, God bless you. Sure? I'm glad. Nice, 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 nice. Okay, so let's go do that raw operation now. So we want to do what? We want to do that one, so we done that. Now the one we are doing is that one. So now we are saying row 1 plus, so for row 1, take row 1 plus 5 row 2. Right, so I'm going to take 1 plus 5 of row 4, so 1. 1 plus 4 times 0 of that is just a 1. And then a 4 plus a 5 times 0, it will still be a -4. And then a -5 plus 5 times 1, it becomes a 0. And then a 0 times a 0 plus 5 of 0 is a 0. Similarly, is a 0. This one going to be 0 plus 5 of that, it becomes a 5. And then a 0 plus a 5 times 3 should be a 15. Any question on this? So I don't understand how the intersection between is equal to -1. Okay, so let me go back. X3 and X. So Pradham, come do this row operation from here. We are saying row 2 minus row 4. Row 2, 0 minus row 4. Is that not going to be a -1, Pradham? The row operation we are doing is row 2 minus row 4. Row 2 here is this. So for that part is 0 minus 1 going to row 2. It should be, unless it's me. Pradham, did I answer your question? Sorry, sir. Yeah, of course. Okay, Pradham, I will forgive you on that one. Now that we have managed to do this part, so we see that now we have this. Any question on the second row operation? Okay, that's fine. Now the second row operation worked. Now, what is my second step? Now I have to again go look what is the most negative number on the top row. Remember, we have to run the exercise until all the top rows are run, the negative on the top row run out. So what will it be? Come on, guys, tell me. Yeah, go. What's the next? What's the most? I done. Brickle, thank you. So how am I going to get my ratios now? Can someone help me find the ratios then? So you're gonna take what numbers and what numbers? How will my ratio be? Thank you guys, you got it. It's right, it's a -4. So that's the most negative number on the top row. I don't understand why we did the first row operation. Was that just a standard operation for a pivot? I explained that after we get this, we of course need to make sure that the only number which have to remain as 1 is that number. Everything else in this thing has to become 0. So which row operation are you talking about, my friend? What's his name? Christina. Which row operation are you inferring? R2 minus R1, or what are you talking about? Because I did this to ensure that this one go away. And I did the second row operation to ensure that that minus 5 go away. So I'm not sure why is that a question, but if you don't understand, ask again. So when I did the last one, I got that. Now, after again, I choose this to be my what? I chose this to be my pivot column. Now to find my ratios, you will take values of B, divide by values of that column. So it's going to be a minus 15 divided by a minus 4. That's the negative. We don't want negatives. The ratios should never be negative or zeros. No, 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 no. Right. Then a 6 divided by 2, that is a 3. Then a 4 divided by 1, that is a 4. And the 3 divided by 0, we ignore. So what is the minimum? What's the smallest one? What will be my pivot, my pivot row? Of course, it's going to be the smallest one, which is what? So nothing there, 3, 4. Now, after I get that, now after I get this to be my pivot row, what value is now going to change? X3 now has to leave, entering what? X1 here. So wherever this X3 has to enter, while X1 has to do what? While X1 has to leave. Sure? But before I do, so is that correct? Do we agree that? Yes, that is correct. So we have that is a row 2. So row 2 is my pivot column. Thank you. Now what I need is now to make sure that every other number apart from the 2 becomes 0 in that column. So I must do row operation. I must find my appropriate row operation to make everything equal to 0 in that column apart from that number 2. Right? So what am I going to do there? And X3 switches with X1. Thank you, Mandisa. Some people are following. Hey, this is nice. Right. Now, I don't like this being a 2. I want it to be a 1. So what row operation must I do to make it a 1? We now update the canonical argumented matrix by pivoting a 2, 1, row 2, column 1 entry with the help of a row operation. Again, we want everything in that column to be 0 with the exception of the pivot element. My pivot element is 2, which is 2 in this case. We again perform elementary row operation by pivoting at the 2, 1 entry. So I multiply that row by a 0.5 to make it become 1. Why do you do that, Ezekiel? It's just my finicky behavior, right, to make it very easy, right? Because I need everything remaining inside to be 1, 1, so I can read my solution very easily at the end. Okay, now, so Ezekiel do the first row operation. That is what it does. And I get, if I multiply this row by a 0.5, it's going to be 1, 0, 0.5, 0, minus 0.5, and a 3. That is how I got that thing. And notice that I switch X what? X3 now is switching with X1. Okay, now we then do another row operation to make the values 3, 1, 0 as well. So now remember, this one remain 1, but this one and this one must become zeros. So I want to find row operation to perform to make such happen. I say I want what? I want I want row 3 to become what? I want row 3, this one, to become a 0. Remember that has to become a 1, but I want this to be a 0. So I'm going to say row 3 minus what? Minus row 2. Notice the trick. If you are changing row 3, you start by saying row 3 minus the other row to make it equal to 0. So here I'm going to say row 3 minus row 2, putting it back to row 3. So I'm going to say 1 minus 1 is going to be a 0, which I put it here. Also, of course, 0 minus 0 will be a 0. And then 1 minus 1 is going to be a 0. And then a 0 minus 0 is going to be a 0. And then the 0 minus row 0,5 is going to be a negative. And the 1 minus 0 is going to be a 1. And the 0 minus 0,5, it should be a 0,5. And then a 4 minus 3 is equal to 1. So, very happy. I got that. Anyone follow the trick? Any question, doubt, concern? Aha, Cabo, thank you for that. Then the next row operation is, can we do it like this? That is for row 1. Going to row 1. Yes, some people are good this thing around managing to understand this thing. Right, so the last one now, remember I got this to be 0. So I need this to remain as 1, but everything else has to become what? 0 now for this. So now it's going to be what? It's going to be row 1 plus 4 row 2. If I do that, it's going to be row 1. So this plus this going to 1. So 1 plus 0 going back to 1 is 1. Minus 4 plus a 4 times this is going to be 0. And then a 0 plus a 4 of 0,5, it should be a 2. A 0 times a 4 times 0 is a 0. A 5 times 0,5, it's going to be a 5 minus 2, that is a 3. And then a 15 plus 12, because that's a 4 times 3, it should be 27. Whew. Now, you have come a long way, and congratulations for being patient, and I hope you have understood. Any question before I conclude what I'm explaining again? That was a correct thing, right? Right, so you have done that step, and then now notice that the top row, does the top row now have any other zeros? Is there any left zero negative numbers in the top row? Not zeros. Is there any other negative number on the top row? And this was say, will it be wrong to say for which row? Right, now because my top row has no more any negative numbers, it means my optimization problems is actually, I have finished solving it. Now, notice this now has no any other negative number. But how do I read my solution? You say when z is 1 and everything else is equal to 0, what number do you get? You get a 27. When z is 1, all other values in that column is 0, you get 27. X1, when x1, you say, where is x1 equal to 1? It's here, and everything else equal to 0, you read the number, is 3. X2, here, where 1, and then the number is 3. For x2, for x3, there is no a column where it is 1 and everything else is 0. So that one, we're going to just say x, because no such exists, we say x3 is equal to 0. So notice this. When we can find a 1, we read the value to be 3. So x2 is equal to 3, x1 is equal to 3, and then x3, there is no a number, there is no a point where this is 1 and everything else is 0. So we're going to say for x3, then it's going to be 0. x4, everything else is equal to 0, and it here is equal to 1. x5, still, we don't have a scenario where we have a 1 and everything else is equal to 0. So x5 has to be 0. Now notice, so your x1 is what? x1, we got it to be 3 when every x1 is equal to 3 when everything else in that column is. So you just check when everything else is equal to 0 and x1 is equal to 3. Here, when everything else is equal to 0 and x1 is 1, 3. This is a 0 because it doesn't have a scenario like this. This is when everything else is 0 and that is equal to 1, you get a 1. That is 0 because there is no any point where we have a scenario where everything else is is 0 when x5 is equal to 1. So that then we get the answer to be 3, 3, 1. Sure? So what does that mean? It means x1 is 3, x2 is 3, x3 is 0, x4 is 1, x5 is 0. And that is how I got this solution. Now, you don't have to do this part, but if you fancy, you'll see that your reduced cost is now the smallest numbers. Now, what does that mean? It means your optimal solution is what? Your z value, the maximum value you can get is what? Is 27. And you get it when x1 is equal to 3 and when x2 is equal to 3 and x4 is equal to 1. So if you come and you put the numbers in your z value, which is here, you should see that those numbers give you a 27. Any question? I want to hear your question now. How do we determine a pivot? Was this guy in my class? Now, some people have really fine name like Emenike. Praise God, Emenike. How do we determine a pivot row? Can somebody help them? We are only changing the base. There is a value entering the bases and one leaving the bases. That's all what's happening. I think I've explained how to determine a pivot row today. Because we are looking to solve for x2 and x3, which is our maximizing what? Our maximizing decision variables. We want to find the values of the decision variable which maximize our objective function. That's why we are interchanging it. It says explain how to get 20. I saw. Okay. So, all right. So let me go back. This is what I did. How to get. Remember, you read up what is your value of x when everything is equal to 0. Theta is a 3. For x2 is a 3 as well. And for x3, it's actually 0 because there is nothing. There is no a point where x3 is 1 and everything else is 0. So the value of it has to be 0. For x4, we have a scenario where there is a 1 and everything else is equal to 0, and that is corresponding with a b value of 1. For x5, similarly, there is a 1 here, but everything else is not 0, so that is not, we give it we assign a value of 0. Okay, now that theta, I got that my x1 and x2 is 3. I can go to my objective function z is equal to 4, and you put it what? You put a 3 there and put a 3 there, and you should get a 27. Somebody says, right, so yes, that is correct. Okay. Now, Okay, so let's see what this guy says. So when we have a minimization, we can stop the finding the pivot row when there is no longer a positive value. That is correct, yes. Then this guy says, so when, okay, right. I understand how we get the pivot column. I don't understand the exchanging of bases to determine the pivot row. We do not exchange the bases to determine the pivot row. We get the pivot row. After finding the pivot column, you take the B values in the B column, divide by those values of the pivot column, and take the minimum, and take the minimum ratio, and that will be your pivot row. Some people were sleeping in this class. So when we interchange, for example, please don't ignore. That is not when we are not interchanging. Yeah. So X is entering and Y, and the only thing we are writing, we are putting X3 there instead of writing X2. I didn't interchange the row. I changed the value, the label there. There is a difference between interchanging and just labeling differently. So let me go back here. People are mixing up here. X1, I'm gonna label this this because this is my pivot row now. So the first thing is I choose the most negative number. It is a -4, and then I take values. So that is a -4 will become my pivot column. That is fine. To get my pivot row, I take the values on the B column and I divide by each value on the pivot column and put them on the ratio. When I do that, I get a 3, 4. Then I choose the minimum in that, and that will be my pivot row. Okay? And then 2 will be my pivot element. Why? Because it's where this is meeting with that. Now I need to hear any other question. Is the pivot row for minimization problem also the row with the smallest ratio? Yes, that is correct. Right. Oh, thanks. I understand now. That's good. Any other question? So the class assignment, which I need all of you to try, is to try set this up. Notice that this is what this have a great this is a greater or equal, and this is a greater or equal as well. Formulate it, don't solve it. Just put it. I need only you to do it up to, where will this be? They won't run away from my class. Just do it up to here. Don't solve it. Just put it in this format. Will you be able to put it in this format? Then I will see. Right? So that is the best thing. I will correct some editing here, and then next time when we meet, we will start doing. So do this as a homework, and this as well. Then try this as well. Try to see that every step is correct. Yeah. Try to see if you can get that. So the next time we meet, we're going to start from a 4.4. Any other question, doubt, concern? Says, do we only look for the largest negative number in the first row when finding the pivot column? Yeah, in the top row, yes. We look for if you are doing a minimization, you look for the largest negative number. Maximization. If you are doing for a minimization, you look for the largest positive number. That's correct. Could this whole problem be done graphically in an exam? Do we choose the method we use? No. We will tell you the method you use, and you must abide with our rules. Another thing I must highlight, some people are using their mobile 92.5 to answer my quiz, which means they're going to have display problems. And they send me 500 emails saying, Ezekiel, I can't see the question. Of course, you won't see if you are using a small screen. So I encourage you to make sure that you do it on a larger screen where you can see things. If you send me an email that, look, I'm doing this thing in my phone and I can't see it, of course, I wouldn't be able to solve because I can't come and give you a bigger screen. So I encourage you to do my quiz in a larger screen where you can see questions. Display problems on the phone, I can't solve them. Maximum is equal to minimum number. Wait, how far must we get up to again for the homework? 4.4 work, homework, yeah, it go to up to 4.4. Why would you get a week off? No, Michael, I'm sorry, man. We have to get as many stuff as possible. We can't just get week off. Week off. This is not high school. Here, you write test back to back. Don't you know like that song like back to back? And you know like a Drake song, you started from the bottom, now here you are going up, right? It's not gonna be easy, my guy. Michael, no week off. We still have to push. So, sir, is the X3 the slack variable? So actual numbers needed to add to the inequality to make the inequality. Yes. Are those the actual numbers needed to make the inequalities equal? Yes. We introduce slack variables to allow us to impose equality and then solve the problem. It says, I have display issue on both my laptop and phone, send an email about it. Okay, then, okay, another possible problem, let me try to answer this again. It could be that, okay, so there's a thing called caches, clearing caches in your computer. If your computer have caches, which is a CA, how do you write this thing again? Clean caches in your PC before doing the quiz. Okay. Yeah, let me put this here. Clean caches in your PC before doing the quiz. I hope that's clear. Yeah, Mozo is correcting my English. You know, my vendor is really bad. Thank you. Hey, you guys are now, I see now you are throwing shade. You're like Ezekiel, it's called catches. Like, seriously? Yeah, okay. Anything else I need to, so hopefully you now, there is no a tutorial tomorrow for optimization. I give you a day off to do my quiz because I want you to do very well before. So tomorrow spend the tutorial time to answer my quiz. Any other question, doubt, concern, hate speech, tell me, I'm here. Yeah, my course is chowing, of course. Why do you think I'm gonna make my course simple? Gonna have to make my course not simple. This one says, sir, can I get another quiz or can I do both? That one, I will actually, yeah, let me reset now and see what happened. This is a guy who had an issue. My first comment, sir. What, okay? Your first comment was, butter. Write it down so I can answer for you. I'm here. All right, now you get a laptop. We are clear. That's even better. Does the quiz cover today's work? Are you sure? Like, coach, you want people to start sending me hate speech? No. Doesn't even involve linear algebra. No, it is not in there either. Yeah, Julian. Yeah, Julian, you can go. Have a wonderful afternoon and a productive week, Julian, and the rest. As those with question, where can you get tutorial solution? From your tutor? You should attend your tutor session. These are the question I don't like because it just means that this student is not attending tutorials. He's just babalizing somewhere. Why do people call me sir? The queen never knighted me. My mom doesn't know I'm called sir. Can you just call me Ezekiel? Like, it's really easy. I don't gain weight if you call me sir. Just call me Ezekiel. It's fine. Constantino says, so sir, in the example is a minimum basis feasible solution. It's a maximum solution. Remember the problem was for maximization, no? See, my problem was maximization. Maximization was my equation, but you didn't read it, did you? It is a maximization. Now she's telling me it's a minimization. But what can I say? Fine. It is a maximization. Bye, everyone. Okay, Julian. Okay. Right. Okay, guys, have right. Okay, so okay, Babalas. Right. Guys, I wish you a wonderful week. Please try to write my quiz very well. Does the quiz include linear algebra? How many times do I have to say this? Ish, yes, yeah, I'm tired now. The quiz does not involve linear algebra. Have a wonderful afternoon. Write my quiz and good luck, and we'll see you. Yes, that is correct, Constantine. You are right. It is a maximum solution with x1 equal to 3 and x what? And x3 and the x2 equal to 3 and the x3 equal to 0, x4 equal to 1, x5 equal to 0. Do the examples in the notes and I shall see you. Have a good one. I'm going to end the session now. Okay. Good luck, guys. See you soon. Sir, you ignore my question. What was your question? Mozo enjoyed my lecture. Glad. Make sure you keep learning. Right. What was your question? So we don't include the Z column when doing the operation. Actually, we do. Just go check again. We did include the Z column. When I did the last row, it was including that. No, I don't know how I can send you emails. Emails of what now? You know, like some people, mtulisi, mtokozisi. What email should I send you? About what? About the quiz or what? You want an email? What does my email should say? I think Moodle send you an email that there will be a test. No, you don't do raw operation before you. I ask if we do raw operation first before we interchange. Interchange. No, that's not correct. Goodbye, Ezekiel. Goodbye, Hope. Have a good afternoon. You ignore it's yeah. So I told you to type the question again so I can answer you. Oh, bless. That I think I've responded. If the quiz multiple choice, you will figure when you are there. Sir, answer me, please. I don't understand what Mtulisi question is. So I'm gonna ask him to type it again so I can pick it. Mtulisi. I know that it should send you in the first 30 minutes. That is correct. Oh, for the lessons, okay, yes, I will do that. I will update and I will put on Discord. How can we see faster than we now have to say that? Yeah, if you are looking for a faster part in my course, go deregister. There is no faster way. You have to do raw operation. I encourage students to check. Moodle before the lecture to see whether the link is not there. Right. So make sure that you make time to do the link. Anyway, I see that stuff where people actually know where to get the link to attend the lecture is. This is the 4th week now. You should be able to see this to know how to get the contact and stuff. Anyway, have a wonderful afternoon. Good luck with the quiz.